Now we are going to put everything together and we're going to be graphing complicated sine and cosine functions. Either I will give you a graph and you will tell me what the function is, or I will give you a function and you create the graph. All right? Before you can do this effectively, you need to make sure you are familiar with all of this terminology that we've talked about over the course of the last few weeks. So you need to know what amplitude, midline, period, frequency, and phase shift are. The first example we're going to do is a graph that I've given you, and I want you to write the function of it. Okay, so we are told that this graph is a sine graph. We know that it's a sine graph because it starts on the midline. So here's my midline that I'm going to write in there. See how it goes right through the middle of that function. And I need to figure out what is the equation of this function. So I'm going to do y equals something. In order to figure out what that something is, I need to know what the midline is, what the amplitude is, and what the frequency is. The midline I just drew in. That's this line right here. And I need to figure out how far up that line is, and I can do that by looking at the y value there. So this midline is y equals 20. So I'm going to say the midline is 20. The amplitude is how far above the midline or how far below the midline I've gone. So if I'm looking at this graph, I'm saying my lowest point is at 13, which is 7 below 20, and my highest point is 27, which is 7 above 20. So my amplitude is 7. Okay. Frequency comes from evaluating the period. So I know that the frequency is 2 pi over whatever my period is. So I need to look at this graph and I need to figure out how long does it take me to complete one cycle of this sine function. So if I'm starting here, I go down, come up to the midline, go up, and then come up back down to the midline. And this sort of S shape is one cycle of sine. At this point right here, it's going to start repeating itself. Okay? So how long does it take it to complete one cycle? Well, it starts at 0 and it goes to 12. All right? This right here is 12. So it is 12 units long. So when I am figuring out my frequency, I'm going to do 2 pi over 12, which simplifies into pi over 6. Okay? Now I have a midline, I have an amplitude, and I have a frequency, so I can create my sine graph. My sine equation. I have the graph. When I'm looking at this, I know that the sine function starts on the midline and then goes down. Normally sine goes up. If it goes down first, I know that it has been reflected. So this is a negative sine function. The amplitude is 7. Okay, it is sine. And then the frequency goes in there with the x. So my frequency is pi over 6, x, and then my midline is 20. Okay, and this is the equation of that sine function. Now, if I have any sine curve, I can change it, or I can write it as a function of cosine instead by shifting it right or left. So if I'm looking at this and I want to figure out where the cosine curve starts, what I can do is I can say, all right, well, where is either a high point or a low point on this graph? And the first thing I come to is a low point. So I can start cosine at a minimum or at a maximum. If I start cosine at a minimum, I have one cycle of cosine. It goes up and it goes down. So this orange right here is a cosine curve. And it doesn't start at the origin, it starts 3 units over from the origin. So this cosine curve has been shifted to the right 3. So if I want to write it as a cosine function, I need to write it with a shift in it, with a phase shift. So I'm going to go ahead and do that. The amplitude and the midline of my cosine are the same. All right, because I'm starting low right here, I know that this also has been reflected. A function that starts low, it has a reflection in it, all right, because it's starting below the midline. Amplitude's the same. It's a cosine curve now. My frequency is the same. It's still 12 units from where I started to where I ended one cycle. This is a length of 12. So my frequency is still pi over 6. But now I'm not starting at the origin. I'm starting 3 units to the right. So I'm going to take this and shift it 3 units to the right. And then I still have a midline of plus 20. Okay? So this is the same curve, just written with a cosine function instead of a sine function. This is some fancy pants stuff. Okay? Now, last thing we're going to do today is take a function that's given to you and we are going to graph it. All right? In order to graph this function, I'm going to need all the pieces that we have talked about. So I need to know, is there a reflection? What is the amplitude? What is the midline? What is the frequency or the period? I'm going to use the frequency to determine the period. Those two go hand in hand. And what is the phase shift? All right. If I can figure out all these things, then I will be ready to graph it. Is there a reflection? Yes, there's a negative sign at the front. So I know that this is going to start below the midline instead of above the midline. The amplitude is 2. All right. The midline is y equals 1, which I'm getting from here. The period is determined by the frequency. The frequency is what number is x being multiplied by. So the frequency of this function is 2. So the period is going to be 2 pi divided by the frequency, which is often given the letter b. So 2 pi over b is 2 pi over 2, which is pi. So this function will finish up in pi units. The phase shift, we are not ready to name the phase shift yet because the frequency has not been factored out. X does not have a coefficient of 1. So before I'm ready to identify the phase shift, I am going to rewrite my function. And I'm going to factor out this frequency. So I have 2 times x minus, and remember when I factor it out, I'm just dividing by that number. So if I factor out a 2 from this, I'll end up with a pi over 2 plus 1. Well, now I can see my phase shift because x has a coefficient of 1, and I know that this function is going to go right pi over 2. All right, hang in there, because now we're going to have to put all of this to use. I'm going to do this in 2 phases. I'm going to graph some helper dots without the phase shift, and then I'm going to put the phase shift in. Okay, so I'm going to sketch my midline in here. And I know that cosine starts in this function 2 below the midline because there's a negative 2. So I'm going to pretend that there's no phase shift now. And I'm going to say that this starts 2 below the midline. And I'm just going to put a little helper dot there. Okay? Now, my period is pi, so it should finish up by pi units right here. My pen is not working. There we go. Okay? So what that means is I have to cut pi into 4 little pieces. So I have this little piece here and this little piece here, and this pi over 2 will be my halfway point. So without a phase shift, I know that I start below the midline, on the midline at my first quarter, above the midline. Here, this pen is being irritating. I'm going to change it. So I start below the midline. I am on the midline at the first corner. Halfway through, I am 2 units above the midline. And then the third quarter, I'm on the midline again, and I'm going to end down below the midline. And this is one phase of this function, one cycle. All right? But I have not accounted for this right pi over 2 situation yet. So what I'm going to do is I'm going to take these helper dots, And I'm going to move each one right pi over 2. So this guy, he's going to come and he's going to move to the right pi over 2. This guy, he's going to come and he's going to move to the right pi over 2. So I'm just shifting everything to the right pi over 2. This guy's going to come to the right pi over 2, and this guy's going to come to the right pi over 2. So what my final graph looks like is that. It starts 2 below the midline. It takes one cycle, is finished up in pi units. I have shifted everything to the right pi over 2, and my midline is at y equals 1. So I think I have accounted for everything I need to account for. So this is one cycle. You could keep going and say, all right, well, if I continue the pattern, this would go up, this would be here. And I could just continue that same pattern over and over again, okay? That's putting everything together. That is a complicated graph. So if you can graph this, you are golden with all things graphing.